In this video, I'm going to be walking through how to use the Poisson distribution. The function for the Poisson distribution is given by this, and x can equal any number and there's no limit. And this means the parameter lambda is equal to the mean, which is also equal to the variance. The first example, the daily number of breakdowns of a taxi can be modeled with the Poisson distribution with a mean of 1.5. So this means is 1.5. Find the probability that on a given day there will be exactly 2 breakdowns. So we want to find the probability where there's exactly 2 breakdowns. And this can be modeled by (1.5) multiplied by 1.5, 2, because there's 2 breakdowns, over 2 factorial, which gives us the probability of 0.2510. Okay, the next question asks us, determine the probability that in a 7-day week there will be exactly 3 days without a breakdown. So read the question carefully. So we want to find 3 days without a breakdown, and therefore we have to find the probability of there being no breakdown, which means e to the negative 1.5, as we found out earlier in the question that lambda is 1.5, multiplied by 1.5 to the 0, which gives us 1, over 0 factorial. And this gives us 0.22313 to the 5 decimal places. Okay, now we want to model this binomially, where p is equal to 3, because it's exactly 3 days without a breakdown. And therefore, you use 7, 3. The probability of success of in the 3-day week, multiplied by 1 minus the probability, and remember these two have to add to the 7-day week here. And this gives us 0.1416. Okay, example number 2. The number of houses sold by an estate agent follows the Poisson distribution with a mean of 2.5 houses per week. So we want to find out where probability is exactly 4 houses. So here we have to plug the values in to the function that we are given. We have 4 factorial, which gives us 0.0189. And this one, more than 6 houses. So we know that more than 6 houses indicates this, which can also be written as this. And to find this out, you can write it as so. And using the calculator, where lambda is 2.5 and the upper limit is 6, you can find that the probability of x is less than or equal to 6 is 0.1301 to the 4 decimal places. So 1 subtract 0.1301 gives us the probability 0.8699 to the 4 decimal places, which gives us the probability of more than 6 houses.